Today's topic comes from the Focus Standard Grade 8 Expressions and Equations Standard 3, where we are dealing with operations with scientific notation. So the topic for this video is scientific notation, adding and subtracting. Our essential question for today is, how are the rules for adding and subtracting in scientific notation, abbreviated with SN, similar to adding or subtracting with decimals or fractions? So take a moment, pausing the video if you need to set up your header. Be sure to include today's date, set up your question column and your note column, and resume the video when you're ready to begin. So as our essential question kind of shows us, we're going to compare adding and subtracting in scientific notation to adding and subtracting with decimals or fractions. So I want to start out today's lesson with a little bit of math recall about the rules for adding and subtracting with decimals and adding and subtracting with fractions. So go ahead and take a moment reading these sentences here and see what you would, how you would fill in the blanks. So before adding or subtracting with decimals, you must always make sure to blank blank the decimal points. Before adding or subtracting with fractions, you must always make sure the blank are the same. So what do we have to remember when adding or subtracting decimals or adding and subtracting fractions? If you said with decimals we have to make sure to line up the decimal points, and with fractions we have to make sure the denominators are the same, you are right on track. So part of the reason that we have to line up the decimal points with decimals is to make sure that we're adding and subtracting while keeping the place values lined up. And similar with denominators, we're keeping the values, they have to be in the same value format in order to add or subtract. So the same principle is going to apply when doing scientific notation. So the same principle applies when adding or subtracting values expressed in scientific notation. Because the power of 10 is telling us what place value it's in, before we add or subtract in scientific notation, we have to first make sure that the powers of 10 are the same. So let's go ahead and get started. We're going to talk about the 4 steps to adding or subtracting in scientific notation, and then do a few practice problems. So here's the 4 steps. First, as I just mentioned, you have to ensure the values are expressed in the same power of 10. If they're not, you're going to move the decimal point of the smaller coefficient and the power of 10 until it's equal. When you're doing this, it's important to note that you may get a value that's no longer in proper scientific notation, and that's going to be okay until we get to the last step. So after you've made sure that they're both in the same power of 10, then you're going to go ahead and add and subtract the coefficients, basically following the rules for decimals. And keep the same power of 10, nothing changes there once you've started adding or subtracting. And then step 4 is where you have to make sure that, if need be, you're going to adjust the decimal point and the power of 10 in the solution to make sure it's still expressed in proper scientific notation form. So again, if you need to, feel free to pause the video here, make sure your notes are complete and that you have all 4 steps, and then we're going to go through a couple of examples of adding in scientific notation. So let's go ahead and take a look at a couple of examples of adding in scientific notation. Here are 2 problems that I've set up for us. So let's go ahead and take a look at the first. We're going to copy this problem down. We have 3 65/100ths times 10 to the 17th power being added to 4 21/100ths times 10 to the 17th. So following our steps, we first want to make sure that they're expressed in the same power of 10. So here we have 10 to the 17th and 10 to the 17th. So step 1, they're in the same power of 10, which means we're looking at this in the same, lined up as the same place value. And so we're going to go ahead and, for step 2, and add the coefficients, since this is an addition problem. So go ahead, our coefficients right here, 3 and 65 hundredths, 4 and 21 hundredths. Go ahead and add those up. Let's check your work. So if you got 7 and 86 hundredths, I would agree with you. And then for step 3, we just keep that same power of 10. So it's keeping it as 10 to the 17th. This number is in proper scientific notation because we have it only goes to the ones place. It doesn't go into the tens. So this is perfect. So our answer is good. Our answer is 7 and 86 hundredths times 10 to the 17th. So let's go ahead and take a look at the next problem. For number 2, we have 9 and 97 hundredths times 10 to the 14th, and we have 8 and 54 hundredths times 10 to the 12th. So right away, here we have 10 to the 14th, but here we have 10 to the 12th. So that is going to be a red flag because they're not in the same scientific notation. So which means these are not actually lined up. Although the decimal points are lined up, they're actually not lined up by place value because this one is smaller, it has a smaller magnitude. So we need to adjust that so that they are equal. So it says, if not, we're going to move the decimal point of the smaller coefficient. This one is smaller because its magnitude is smaller. And the power of 10 until it's equal. So let's take a look. We need to go 2 place values greater, 2 place values greater to get up to 14. So that means we're going to take this decimal point, we're going to move it once, twice, towards a greater scientific notation. So what would that look like? It's going to look like this. Notice it was here between the 8 and the 5, but we moved it once, twice. So now, since we increased the place value 2, we increased up to the power of 10 twice. So now they're in proper form. Here we have 10 to the 14th, 10 to the 14th. We made that adjustment by moving the decimal place 2 place values. And now we can go ahead and add the coefficients. So take a moment doing so. Go ahead and add 9 and 97 hundredths to 0 and 854. 0 and 854 10,000ths. Let's see how you did. So adding these up, we should end up with 10 and 554 10,000ths. Keeping the power of 10, so we kept it as 10 to the 14th. But as you can see, now we have an issue with step number 4. We need to make sure that it's in proper scientific notation. Scientific notation, the coefficient can't go past the ones place. So we need to move our decimal point from between these 2 zeros to here, so that it's in proper form, which is also going to mean that we are increasing our power of 10 because we're moving the decimal point. So, adjusting our answer, moving that decimal point from here to here so that our coefficient is in proper notation, increases our place value by 1, so we increase our power of 10, 1 power, and so our final answer is 1 and 554 100,000ths. So take a moment jotting any information down that you need to, making sure that you have these problems copied into your notes, and then we'll be ready to take a look at 2 subtraction examples. So let's take a look. Here's our first problem. We have 7 and 36 hundredths times 10 to the 15th, subtracting 2 and 14 hundredths times 10 to the 15th. So remember, step 1, we want to check our powers of 10 and make sure they're the same, and they are. We have 10 to the 15th and 10 to the 15th. which tells us that we're dealing with numbers that are in the same place value. So our decimals are lined up, and we're ready to go ahead and subtract these values. So go ahead and do so. Remember, we're going to keep the power of 10 to the 15th. And let's compare and see if we agree. So subtracting those coefficients, I got 5 and 22 hundredths. I kept the power of 10 to the 15th, so our final answer is 5 and 22 hundredths times 10 to the 15th. Everything's in proper notation, or scientific notation, so this problem is done. So let's look at number 4. We have 6 and 5 hundredths times 10 to the 25th, subtracting 9 and 28 hundredths times 10 to the 21st. So, checking our powers of 10, here's 10 to the 25th, but this is 10 to the 21st, so that's a red flag because they're not in the same they're not both in the same power of 10, they don't have the same magnitude, so this tells us that they are not lined up by proper place value here in our coefficients. So we say, okay, well this one has the smaller magnitude, what do I need to do to increase it up to 25? If you said increase its place value by 4 or its magnitude by 4 place values, I would agree because 21 is 4 less than 25. So it means with our decimal point here, we need to move up 4 place values and take another look at this problem. So the place value was between the 9 and the 2, but we've moved it up 1, 2, 3, 4 place values, which increases our power of 10 or our magnitude by 4. So now they're both in 10 to the 25th power. So now when we line up our decimal points, we know that they're now lined up by the proper place value. And we're going to go ahead and subtract these values. Remember, you're going to have to do some borrowing here to be able to subtract all this. So go ahead and do so, and then pausing the video if you need to, and then resume to check your work with mine. So if when subtracting these two values you ended up with 6 and 49 72 million times 10 to the 25th, I would agree. So here, when we did our subtraction work, after making sure our powers of the 10 the same, our answer was still in proper scientific notation. Our coefficient doesn't go past the ones place, so we can stop right here, as this is our final answer. So let's go ahead and conclude our video today on adding and subtracting in scientific notation. So please take a moment to make sure that your notes are complete and come ready to do more work with problems like these in class.